Hello, today we are going to talk about machine learning for natural language processing. Yeah, let's talk about what is natural language processing or in short NLP. NLP is the field of computer science and AI that enables computers to understand, interpret, and respond to human languages with machine learning. These systems don't just follow rules, they learn from examples just like we do. From Google Translate to virtual assistants like Siri, NLP is becoming an invisible yet essential part of our daily lives. Let's explore how machine learning makes it all possible. Now let's talk about what is NLP. Natural language processing is a bridge between human language and machines. The idea is to allow computers to read, understand, and generate text or speech in a way that feels natural to us. Think about how you ask your phone for weather or how Gmail suggests replies to your emails. That's NLP at work. It's not just about translation or voice recognition, it also needs in used in Google search engines, social media monitoring, legal document analysis, and much more. NLP helps machine break down our messy, ambiguous human languages into structured data they can work with. Now let's talk about what is machine learning. Yeah, machine learning, it's a method in AI where systems learn from data instead of being explicitly programmed. Imagine teaching a child what a cat is showing by them many pictures. Eventually, they will start to recognize cats on their own. ML works in the same way. These are different types. Supervised learning uses labeled data like movie reviews labeled as positive or negative. Unsupervised learning tries to find hidden patterns in data without labels. Reinforcement learning involves learning through feedbacks and rewards, like teaching a robot to walk. In NLP, machine learning helps models understand how humans use language, even when it's full of slang, errors, or emotions. Now, let's talk about how ML powers NLP. Machine learning is the engine behind modern NLP. It starts with converting text, which is naturally messy and unstructured, into numerical representations like vectors. These are often done using techniques like TF, IDF, or word embedding. Then we use ML algorithms to learn patterns from these numerical representations. For example, a modern might learn that the word happy often appears in positive reviews over time. The system learns association between words, phrases, and their meanings or contexts. That's how NLP applications like chatbots, summarizations, and questions answer systems become smarter. They have trained a huge data sets and continuously learn from them. Now talk about common NLP tasks. NLP covers a wide range of tasks, each designed to help machines understand and process language. For instance, let's talk about tokenization. Breaks into words or sentences like turning I love NLP into I love and NLP. Parts of speech tagging. Labels each words with its role in a sentence. It is a noun, verb, or adjective. Now let's talk about name entity recognition. Finds a specific name, date, or places in a sentence. For example, recognizing Barack Obama as a person or January 1st as a day. Now let's talk about sentiment analysis. Figures out the tone or mood of a message. Is someone happy, angry, or neutral? Now let's talk about translation. Convert texts from one language to another. Each of these tasks play a role in how machines interact with languages, and most of them are made possibly through ML models trained in huge data sets. Now my friend Sai Saket Community will continue with the rest of the presentation.
Hello. When it comes to tokenization, next please. Next slide. Thank you. When it comes to text classification, it is one of the most widely used application of in NLP. It involves assigning predefined labels or categories to pieces of text. For instance, when it comes to emails that can be classified as spam or not spam, and even for the reviews too, it can be labeled as positive, neutral, or negative. When it comes to articles, it can be tagged as categories like sports, finance, politics, and so on. First to do this, we first represents the text numerically using techniques like bag of words, TF, IDF, or words embedding. We train the machine learning models like an naive Bayes and then support vector machines or logistic regression on labeled examples. Over time, the model learns which words or patterns are linked to certain categories. Once trained, it can classify new unseen text with surprising accuracy. This is especially used in context modelization, social media analytics, and then custom feedbacks. And then the next slide, please. Yeah, when it comes to sequence labeling, unlike text classification, which looks at entire documents, sequence labeling focuses on each word in a sentence. It is used for tasks where we want to label or tag individually words which specify information. Let's take uh, part of speech tagging as an example. Here, every word is labeled as noun, a verb, or adjective, or a etc. Another example is named entity recognition, where we mark specific words as person, location, organization, and so on. These labels help machines understand the role and meaning of words in the context. This is particularly important in complex NLP tasks like question answering, or machine translation. To achieve this, we use techniques such as hidden models, HMM, and then conditional random fields, CRF, and recurrent neural networks, RNNs. These models are designed to consider not just the current word but also the words around it, making these predictions more accurate. And then when it comes to supervised learning in NLPs, supervised learnings is one of the most common approaches used in NLPs. It involves training a model using input-output pairs. In our case, pieces of text with known labels. Let's think of a data set of 10,000 tweets labeled as positive, neutral, or negative. When we feed these into an algorithm, which then learns as associative specific words pattern with certain labels. Once trained, these models can analyze new tweets and then predict their sentiment analysis, and then detecting hate speech online while filtering spam too. For the successful supervised learning depends on quality and the size of the training data. And then when it comes to unsupervised learning in NLP. Unlike the supervised, um, these learning works without labeled data. Instead of being told what to look for, or the model tries to find the patterns and structures on its own. One popular use in NLP is topic modeling. For example, using algorithms like LDA to cover hidden topics within a collection of documents. Say you feed thousands of new news articles into the model, it may discover that some articles are about sports and others are about health or politics, even though you never told it those categories. Another application is clustering. When similar documents or words are grouped together. This is useful in recommendation systems, content grouping, and then exploratory of data analysis. While unsupervised learning doesn't give direct predictions, but it's extremely valuable for discovering insights in large volumes in text. And deep learning in NLP, deep learning is the most used NLP in recent years. Traditionally, machine learning methods often require manual featuring engineering, like selecting keyboards, building frequency counts, etc. But deep learning changes the game. It allows models to automatically learn complex patterns and then represent from the raw data text. It starts with word embedding, word to vex and then glovey, that turns words into high dimensional vectors, capturing relationship between words based on the usage. For example, the vector for king minus man plus woman gives you something close to queen. Uh, then king, and then the RNNs and then LSTMs, which are the great for sequence data, but even more powerful are transformers BERT and then GPTs. They can understand context between the real world and real words in the sentiments at once, not one at a time. That's why models like ChatGPT can generate long paragraphs and even hold conversations. Deep learning has taken NLP for rule-based systems to truly intelligent language models. And then from here, my friend Relax would be continuing. Thank you.
Uh, Thanks, Saket. Yeah. So going to the next slide for NLP data sets. To train machine learning models effectively, especially in NLP, we need lots of high quality data. The more diverse and representative the data, the better the models learn to handle real world exam language. Some popular datasets includes IMDb reviews used for sentiment analysis. Each review is labeled as positive or negative. Twitter datasets often used to analyze trends, hashtags, or public opinion. News article datasets useful for tasks like summarization, headline generation, or topic modeling. Before we feed the data into models, we need to pre-process it. This involves cleaning the text, removing punctuation, converting into lowercase, removing stop words like the or an, and steaming or limiting words to their base forms. Pre-processing makes the data uniform and helps models focus on meaningful patterns instead of noise. So going to frameworks and libraries, NLP task efficiently have some powerful libraries. NLTK is a greater for learning and prototyping. It includes tools for tokenization, streaming, and more. Spacey is fast and efficient for industrial strength. NLP, it's a great for tasks like named entity recognition and dependency passing. Skip-learn machine learning framework provides for basic machine learning, including text classification. Hugging Face Transformers is good to library for working with large pre-trained models like BERT, robots, or ChatGPT. You can load models with just few lines of code. So deep learning tasks, we can use TensorFlow and PyTorch, which offers flexibility, build, train, and fine-tune custom NLP models. These tools makes much easier to build smart language applications without starting from scratch. So going upon with real world applications, NLP have countless applications interact every day without realizing. Virtual assistant like Siri, Alexa, Google Assistant use NLP to understand spoken commands and provide answers. We have some chatbots widely used in customer service, helping users 24 by 7 by answering questions, booking services, or guiding them through issues. So, some email spam filters use text classification to catch unwanted emails. Document summarization tools help condense long reports or articles into short, readable summarizes. Speech to text systems convert voice input to written text useful in dictation apps, subtitles, or accessibility tools. NLP is helping business save time, improve customer experience, and make smarter decisions by understanding language data at scale. So we have some challenges in NLP. Despite all the progress, NLP still face several key challenges. So one of them are ambiguity is a major issue. Take the word bank. If it could mean a river bank or a financial institution, context is crucial, and even humans sometimes misunderstands. Sarcasm and emotions are hard to detect. For example, if someone Tweets greater another Monday. It may sound positive literally, but it's actually negative. Multilingual processing is another hurdle. Many languages lack enough training data, making it harder to build models that work to everyone. Finally, bias in training data is a serious concern. If the data is model learned from contains stereotypes or unfair associations, the model can reflect and even amplify those bias, leading to unfair discriminatory outcomes. Solving these challenges is essential to make NLP more difficult, robust, fair, and inclusive. So finally, concluding and some future trends to warm up. Machine learning is a foundation of modern NLP. From chatbots to search engines, it helps machines better understand, generate, and respond to human language. With deep learning and transform models, they have moved from basic keyword matching to as context-aware language understanding. Looking ahead, the future is even more existing. We will see multilingual models that can understand hundreds of languages, more low-resource NLP, where systems work even with limited data. Emphasis on ethical AI, ensuring fairness, privacy, transparency in language technologies, and of course, larger and more capable models that feels increasingly human-like in conversation. As we move forward, it's important to balance innovation with responsibility. As coach says, language is the roadmap of culture. Understanding it well is a key unlocking the human potential in digital world. So thanks.